All right, success. um, let's see here. Yeah, I don't know what was going on there. I test all this stuff out ahead of time, and then like I go to stream, and OBS is not doing the thing. It says it was connected, but not actually streaming. Okay, so apologies for late start here. I guess I have that open already. Let me defluster myself slightly, and we'll get started. I actually had to reboot to get OBS to do its thing, so some of the prep work I did here is being thwarted by that. Yeah, sorry, give me just a second. I didn't want to delay the stream with people waiting to do this, so you can see some live stuff here. No. All right. Videos. Yep, this one. To do its thing. So okay. Get the chat out here. Pop out the chat. And get to see all the behind the scenes of my weird setup. Okay. So, yeah, so I don't know how many people, I think the ratio of people who like tweets versus you actually show up to a live stream is very, very, I guess very, very large on the like tweets side and small on the show up to the stream side. But there was a significant attention on Twitter, so I want to say a few things at the beginning to set expectations and talk a little bit about what we're doing. So Sam Williams, I don't know what he would like to be referred to as, a leader of the Arweave effort here. Very kindly tweeted this about the stream. I want to clarify a couple things here. First of all, star programmers, that's up to you. I think the important thing when you're developing software is to focus on, whether you're working on worthwhile things and, whether you're providing a useful contribution. And, if you want to try to improve yourself, just always judge yourself against yourself, not other people. So, but that's one thing. The other thing I want to clarify a little bit here is this Arweave node part. So if you're showing up and expecting me to be demoing at the moment, building a full Arweave node in Clojure, that's not exactly what's happening. I'll talk a little bit about exactly what I'm building and how all the things relate, just to set context a bit here. But if that's what you're here for, that's not happening yet. That is something I really, really want to do in the long term, but I'm building this distributed pool, and building my own complete implementation of Arweave is definitely not on the critical path there. That's more something I really hope to do once, once it's farther along and I'm generating more revenue in some way or another. So just wanted to get that out of the way in terms of context. I also want to mention, I'll probably go over into it a little bit, but since the Open Web Foundry is going on, which is sort of it says right here, it's an incubator, accelerator for early stage projects building on Arweave. They have a stream that starts in 45 minutes. And if this is something, actually, I'll just drop this in the chat too. If this is something that seems like it might appeal to you, make sure you go check that out. Don't just hang out on this stream if that's appealing to you. And of course, this is being recorded. I was post recording, so if you're interested in what's going on here, you can catch up via the video. Of course, same for the Open Web Foundry, but it's a little bit harder because there's live interaction that happens after the presentations there. So I do encourage you to go see that if that's appealing to you in 45 minutes when it starts, and I'll try to mention it then because I'll probably go a little over since I started a little late. Probably do a little more than the hour perhaps. Okay. I think those are the main things I wanted to mention as preliminaries here. Close these. At least Brave remembers all my tabs, so I could recreate all this because I had all this set up nicely before I had to reboot. Okay, so let me also get my notes up as backup here. Don't look at the notes; they'll spoil the things I'm about to draw. Okay. So I want to give a little context about what's actually being built here, and I am going to show some stuff about modifications to the Arweave node that's written in Erlang. So if you showed up for that kind of thing, um, there will be some of that, but it's not as extensive as me writing one in Clojure right now. But with that out of the way, so what am I building? So I'm going to start drawing here and explain as I go. So the thing that's being built here is the Strongpool. That's the name of the distributed mining pool in progress. The Strongpool node. So this is a thing that a miner would run, and perhaps others in the network would run to perform other roles. And what's in here is, so we've got this whole big outer box is going to be the Strongpool node. Then within that, we've got Arweave, and I'll explain what this other outer box is here. So this is the Arweave node, Arweave server, maybe I should say. Then we're going to have the, actually let me not put that on top and put that inside. It'll be a little cleaner. So this is Arweave. So the Arweave server, the official Erlang Arweave server. Then we have the engine. That's the Strongpool engine. Oh yeah, I forgot about that. Excalibur is great, but it does not. I wish it attached the text to the boxes. I'd have to be a little tidier about my initial drawings here. Okay, and then we're gonna have other stuff here too. So we might have a gateway potentially. I'll explain that more in a second. Maybe some ops monitoring. Yeah. Yeah. Let's say offset mon. So operational monitoring stuff might be in here too. And this whole thing is inside of Docker Compose. And then outside of this is, and I think I'll make a circle for this because it's SPNCTL. So this is the Strongpool node controller, sort of following a naming pattern similar to like kubectl or something like that. And then it's going to kind of interact with Docker Compose and potentially, directly with some of these things too. Don't want to be too, whatever. Might interact directly with some of those. And then, just to get the full context here, out here somewhere we have the weave. So this is the actual contents of the Arweave network. I refer to it as the weave. I don't know what, some people say the permaweb. I think the permaweb is a little misleading when you're talking about the whole thing, so that's how I've been referring to it. Terminology is probably still evolving there. So the main interaction in terms of what the pool cares about is this. Maybe also, this. Okay, so what's going on here, and what's the motivation? So the pool needs to have proofs of people's work so that it can, it can properly divvy up tokens that are received by the pool. And the way it does that, let me also put a little arrow. My arrows are risking making this completely unprocessable by human brains. But anyway, so the way it does that is the Arweave node is going to dump out these weak proofs of work. The Strongpool engine is then going to take them and it's going to write them to the weave. At some point, the engine running here or elsewhere, there'll probably be other nodes, but I don't want to clutter this too much, will take all those partial proofs of work that are out there, tally them up, and then also send a distribution plan to the weave that the engine eventually receives and then distributes the tokens according to that. You may or may not have followed all that. The main point I want to make is that the engine is here basically to facilitate interaction with the pool protocol and runs adjacent to the Arweave node. You also might want other things here. So, I think one thing that's a little different about Arweave as opposed to many cryptocurrency projects or crypto projects in general is that this is actually a storage server. So it's got data in it that has utility to people, and they want access to it. And so if you want to serve data in the Arweave network, yeah, you're mining to provide security, but you're also running this thing to actually serve data. And as such, you might want some operational monitoring components to make sure this thing is running the way you want. It's just a more complicated thing than a node that's just sitting there doing like proof of work, proof of stake, something like that. And the Arweave node doesn't provide everything you need in terms of accessing the Arweave network. There's also gateways that sit on top of the Arweave nodes that do indexing, facilitate sort of higher level interactions with Arweave. So if you want to interact with Arweave, say with GraphQL, you end up going through a gateway that's then indexing data from the Arweave node. So the Strongpool node is really just a bundling of all these things. It's serving as a way to distribute this whole combination of things, and also as a way to facilitate updating these things. So if you have a bunch of users out there who are participating in the Arweave network, and a new release comes out, you want the process for them to update to the new release to be as seamless as possible. And so this is a way that I can package all these things, in a way that I control, as opposed to, being subject to however the Arweave team is packaging. And then the update process should be as simple as git pull, stop, start. That should do everything for you. Okay, so hopefully that provides a little context. The thing I'm building here is this whole big packaging, and that entails some modifications to Arweave, building this engine thing, and then building this overall packaging. So having like Docker Compose and this nice utility for interacting with all of it. Okay, let's check my notes here, see where I am. So, yeah, I had a few other things I might say about, let's see, what are my notes? Yeah, I may come back to these. I don't want to do too much up front in terms of blasting people with diagrams. Okay, so I don't want people who showed up thinking, oh, this is going to be building an Arweave node, the Arweave itself part live, to be completely disappointed if you're hanging on or watching this afterwards. So I will show, so this is my branch of the Arweave, the Erlang Arweave server. I just thought I'd show the modifications that I have so far. So we'll do a diff with master. Yeah, so this is showing differences between the official distribution and what I've done. And you can see there's a lot of actual just like build automation stuff in here, which honestly, I think if I look at how I spent my time working on this project, probably the majority of it, I think, has been automation of some kind. And I may come back to that. I actually think that's right. That's the right split of how you spend your time on projects, with the small caveat of, like, if you're building something as a business, you need to kind of determine market fit. But in the case of a mining pool, clearly there's a market for mining pools. We don't know how big it is in Arweave yet, because you can still kind of make it as a solo miner currently, at least in Arweave. But over time, like, it's just obvious, mining pools dominate because there's only so many blocks in a chain. The only question about this particular pool is, like, how attractive is this fully distributed nature of it? Time will tell on that, but if you make it at least as usable on just as a pool in itself, people won't really care about the distributed part. So to some extent, I'm just assuming I have a market fit. There's some questions about the size of the market and what the return on that is. But within that context, I think what you really want to, now I said I wasn't going to go into this right now, and now I'm doing it. So I think within that context of, like, okay, I know that there's a market for this. Size is in question, right? So I gotta figure that out over time, but you'd expect it to grow as Arweave grows. Within that context, what I really want to optimize for is sustained development velocity over time. And if what you do in the beginning of a project is you quick ship out like a really hacked together prototype with no sustainable process for developing that, yeah, your initial development will be very fast. You'll probably get something out there. Like I think I could have gotten something out there probably in the first month if I wanted to. But if I did that, I know that ultimately I would end up spending a lot more time. So I'm trying to do, incremental. You do need to be releasing stuff, um, but build the feedback and automation systems as you go so you can sustain that over time. It's also just important to have, I think, feedback systems from a psychological perspective. It's really easy to burn out if your cycle time looks like, oh, I'm going to grind, release something. Maybe it just doesn't get traction, and it's like, oh man, that was a grind, and I'm going to have to do that again for the next release. So you really want to try to make that feedback cycle continuous and smooth. So I've been putting a lot of effort into that. Um, I think there's a whole bunch you could say too about trying to build like a community feedback system. I've also been doing a bunch of thinking and prototyping on that too. But I don't know if you showed up to hear that, so I'll stop myself there. Okay, so anyway, that's what you're seeing is there's a lot of automation stuff built in here. Yeah, I had to remove something there too. Dockerization. This is worth talking about too. I think so far my perception in the Arweave ecosystem is Docker is underused, and I think folks could benefit from Dockerizing more things. So even if you're using a node project and you think it should be really easy to do, just like npm install. If people want to run your stuff in production, really good tools for deploying Docker images in production in all kinds of environments. Like every cloud platform has that. Um, people who run Kubernetes clusters, they have that. So I think it's worth taking the time to Dockerize things well. Just some advice there. Okay, so getting into the actual modifications to Erlang here. So the main thing that you need to build a pool, right, is you need to be able to tally up the work that people in the pool are doing. And I've done sort of the minimal version of that. It's not sufficient for a public pool because people could cheat with the way I've written it right now. But basically what I've done here, let me go down to, actually let me get this up too. Okay, so the file I opened here, again, this is in the official Arweave code base. It's, I'm looking at my branch, but it's mostly the same. This is the mining algorithm. So this is armine.url, it's all Erlang. And the modifications I've made, it actually extends some down into the C code, but I'm not going to spend too much time looking at that, is really not that much. So let's just look through the file here. So we're starting here, going down to about here, so it's like, I don't know, maybe a page of modifications, not that much. And essentially all it's doing is on each round, so each new block that's being produced, the miner is trying to do its hashing thing, producing a hash that clears the network difficulty. If it doesn't clear the network difficulty, we need to somehow record that work that was done so we can tally up the pool contribution. So this is just taking all the hashes that are produced, and for each hash that's produced while it's trying to clear that network difficulty, we compare it to the previous best hash, and if it's better than that, we keep it. If it's not, we throw it away, and then at the end we write that out. So the way that looks, I think it's probably going to be a little easier if I show it over here. Best best hash. Yeah, so there's an ETS mining state where I'm just stuffing this best hash, and this is the code to print it out at the end. So we just grab it out of there, look it up, do a little bit of encoding here. And by the way, nothing I'm doing here should be taken as exemplary Erlang code. I'm still like an Erlang noob, so I'll hopefully get better at that over time. Yeah, so that's just the code to write it out. Then down here, Basically, this is the part that extends down into the C code too. Some of the hashing logic is in C, and basically you run this hasher. What comes out of here is true if you got a hash that cleared the difficulty. So that's this branch. This is already here. Um, it's it's false if we didn't find a hash that either cleared the difficulty or was better than our best known hash. And then it's false with the best hash if we have a new best hash. So this is the new branch here. And the thing we're doing is, okay, we take the best hash, the new best hash that we have, and then we insert it into this, this ETS structure just to keep track of it. That's really it. There's just a few different places you have to do this to keep track of that. And then we print it out, or write it out to a file at the end. I do print it too, but that's just more for debugging than anything. Yeah, and you can see the writing to the file here. So this is enough basically for me to get everything working end to end. So when I'm developing new things, especially getting to code I don't know that well, I'm always trying to thread a needle through it, get things working end to end first, and then kind of expand from there. Because I could get stuck there's more that needs to be done here. What needs to be done is you need to put enough in that file so that you can validate it. Otherwise, people can cheat in the pool. They can be like, "Oh, I made this hash. It's the best hash ever. Look, it's it's 5 times the difficulty. Give me all the tokens." You could do that because I have no way to validate the hash and what I'm printing out. I'm just printing out the height, the hash, and the reward address. But doing that now wouldn't actually help me get the whole system working. I can just run a private pool with people I trust, get the whole algorithm of the pool and the structure of the pool working, and then come back and do this. It's not. I know what needs to be done there. It's not. It's not rocket science. But it's not actually getting me that much closer to the goal right now if I do that. And the goal would be have this whole thing working so I can look at the system as a whole and see how it behaves and refine from there. Once I have that, I can go back and do things like, let's actually print something that you can validate or write something that you can validate. And then also add an endpoint to the node that lets us validate it. So there, that's a little glimpse into the Arweave Erlang code. If you keep viewing these videos, attending the stream, I mean, hopefully I do. At some point, I will get into actually writing more Clojure that's Arweave node-ish. I would probably start with a gateway and then work towards a node. But at the very least, you'll see probably me digging into the Erlang code more, which could be interesting. I hope it's interesting. Okay, so that's taking a look at the Arweave Erlang code. I'm always self-conscious when I say Erlang too, because I feel like I used to say Erlang, and I think that's very not the way you pronounce it, and so I'm always trying to say Erlang. But even that, I'm not sure if that's the way you pronounce it. I should go listen to Joe Armstrong pronounce it a few times and get that solid in my head. Right. So other things that have been promised. Don't want to disappoint people here when I'm putting a stream out there, and I've said stuff about Babashka and RCF, and I really want to show that, especially RCF, because RCF. Yeah, let me talk about RCF a little bit. So this is not directly Arweave related in any way, but it is a Clojure related, and it's something I think is super cool. So Dustin Getz and company from the Hyperfiddle guys here, they put together this little REPL first test macro for ClojureScript, and I think it's super cool. It really fits very well with how I like to write code. It works in Clojure and ClojureScript, which is great because I'm going to be writing primarily ClojureScript, I think, but at least at the beginning. But I do some testing in Clojure too, so I can use this in every place I need to. And what it is, first of all, for those who are not super familiar with Clojure, let me just get my REPL connected. Very common way you develop Clojure is, you have, all right, so I'm going to get my buffer loaded then I'll talk about it. Okay, yeah. So a very common way to develop Clojure is, I have my buffer. There's a bunch of Clojure code in here, and I'll put something like a comment form in here. So the way the comment form works is it's basically just a macro that takes the body and throws it away. But most editors will let you go into your comment form, evaluate things inside it. So it's a really convenient way to make like a little scratch pad in your files. And actually, if you go look at let's see, Clojure core GitHub. Sure, I'll get you there. If you go look at the actual Clojure core code, I think you'll probably see oh, not in that one. Well, I'm not going to dig around for it. Anyway, if you look at the actual Clojure code base, I'm pretty sure there are some examples. Let's maybe Zip. Zip might be one that has it. Yeah, here we go. So here's actual comment in the source code of Clojure itself. That's just like, oh, let's play around. It's hilarious. It's actually got a file from Rich Hickey, Clojure creators. Presumably he had this somewhere. That's awesome. So yeah, there's little comments in here where, the typical way you develop Clojure is you write some code, then you play around with it in the comments. And so, like, I'll just grab a little example here from. All right, so I'll grab that. So here's a little function that's above, and I'm going to evaluate that. It's like, okay, cool. I can see it's doing. Oops, sorry. Let me get that out of there. Getting ahead of myself here. So yeah, okay. I pass it a config that says mine is true. It's going to output space mine as the arguments to Arweave. Great, doing what I expect. And I think this is a great way to develop. It's very interactive. You get feedback fast. Getting back to my broader feedback point of like, I don't like that. Write a bunch of code, compile, run, figure out your code is wrong, go back, write a bunch more code. Like, you want to be working in really small increments so you get feedback fast about failures, sort of generating the minimal failure at any point to get you information. And this really facilitates that. Okay, so this is sort of the way that many Clojurists work. Probably not everyone, but a lot of Clojurists work this way, that you write a little bit of code, you have comment, and then you run it, interact with it. That's great. The problem with this is, these are just comments. They're great for the interactive development, but they don't really help you much with regression testing. I also just want to acknowledge some prior work here. Cognitect Labs. Hopefully I can find this quickly. I may not be able to. Anyway, I just want to acknowledge that this is not the first attempt to do something. Oh, here it is. Yeah, okay. So, yeah, I can talk a little bit about this. I wish you had more code in the thing here. Anyway, what I'm basically getting towards is that there's a way you can write these where they're useful for both development and they're useful as regression tests too. And so, your interactive development is basically building a regression test suite. And there's a prior effort to do this. I mean, I think it's probably still actively used by Cognitect folks, called Transcriptor. Stuart Holloway wrote this, and it's basically a different variation of the same idea. I don't want to get into that because it's not actually what I do, but it's also trying to take the same approach of like, okay, let's make the thing you're doing for interactive development be the tests. Okay, bunch of context. So what's RCF within that sort of context? So RCF is, instead of having a comment, you have tests. I've configured my linter so that it basically treats tests as if it were a comment block. It just ignores stuff inside there, mostly. You can put strings in here that are descriptions, test addition, and then you can do +1, 2, and that should equal 3. Okay, so now I mean, first of all, I guess I can evaluate my expressions. So I'm just evaluating the previous expression here like I normally would within a comment block. It's a thing you can do. The other thing you can do is let's evaluate the whole buffer. So I don't love the way that Emacs gives me the output for this. I'll probably be trying to fiddle with that and make it better for myself. But if I evaluate the whole buffer now, oh, check marks, cool. So let's see, can I see this, that server maybe? Cider. Well, let's show a failure. It will show some output if I have a failure here. So 1 plus 2 does not equal 2. So let's evaluate the buffer. Yeah, so 3 not equal 2. Not good. Not good to be failing tests. So I really, really like this. It's very close to how I would interactively write, just throw away test code in a comment block. But after the fact, you can run these in your, as unit tests, essentially regression tests, whatever you want to call them. So you develop interactively as usual, and you're basically building stuff that provides regression testing for you. So I think that's super cool. Really fits the way I like to develop. It's still a relatively new tool for me, so I don't know. Maybe I'll hit some stuff that's, makes me question it a little bit. Usually happens, but so far I think it's really, really, really nice. And it works well in ClojureScript too, which is great because not everyone writes stuff that works in both Clojure and ClojureScript. Okay, so I think that's given enough context on RCF. I should say where I am here too. So this, if we go back to my diagram for a second, the file I'm in is within this thing here. Yeah, I should have diagrams every time. I think that really helps contextualize. So it's actually part of the controller script. And it's super hackish code. The way I develop often is to just get the minimal thing working, try to make sure the interface is what I want, more or less, but really just hack out a really gross, messy first version. As long as the interfaces are okay, in terms of what I'm exposing as a stable thing that other people will build on, you can clean that up. So that's what I want to do right now. So I have this really, actually, let me leave that there. I have this really nasty bit of code here that's like taking a string and it's threading through and doing a string concatenation, and it's just horrific. So I want to start to, sorry, I should give one more piece of context. I want to start to clean this up and make this, build a vector first and then take the vector and do string concatenation and just clean it up a bit. And I want to do that interactively with RCF. Hopefully that will give you a flavor of what that looks like. Okay, so one more piece of context here. So this is actually all run via Babashka, which is awesome. I should give a little context on what that is for non-Clojurists. So with Clojure, you have a few different dialects of the language. There's Clojure, which is the sort of original JVM flavor. There's ClojureScript, which compiles down to JavaScript. And then there's Babashka, which is basically the Clojure, the JVM flavor of Clojure. However, it's compiled into a binary ahead of time. So the Babashka utility itself is compiled into a binary ahead of time. And then the Clojure code that runs through it is run through a little interpreter, which is slightly different, but mostly the same as the JVM Clojure. That's glossing over a lot of detail, but you can mostly think of it as JVM Clojure that's interpreted, so the code executes slower, but it's the runtime itself is binary compiled, so it starts up very quickly. So when I do BB, like, very fast to start, versus, say, CLJ, a bit slower. And, that's noticeable if you're writing a script and running it a bunch of times. So Babashka is super nice for scripting. So all this code is running in Babashka, but I actually do my development and testing of it in Clojure. And the reason for that is, you get all the really nice tooling in Clojure. that some of it may be trickier to get to run in Babashka. And so far that approach has worked out just fine. I mean, you can include all the regular Babashka libraries in Clojure because it's essentially the same thing, it's just compiled differently. So I develop in Clojure and run in Babashka. And then the, just to give a little demo here, I guess I'll just run that. So it's just a little command line utility here. It's like, oh, cool, I validated my config. You could start and stop the node with it, that kind of thing. Just trying to provide a nice user interface for people using the Strongpool node. Okay. Yeah, so let's start breaking this thing apart. So let's grab this. We could just refer to that, right? Yeah. Okay. So here we have base, no, config, base, config. Okay. So that's what that looks like if we print that. Just pretty printed the variable there. Okay. Okay, if we run that through, let's grab this again. We run that through our argument formatter here. What do we get? It should work because I'm actually using this thing. Now it's not going to. It's definitely going to be the wrong output for it. Okay, yeah. Yeah, so you see the output of that is the string, which is correct, but the way we're building it is not. Actually, now I look at it, that looks a little off. Should be a space in there. Huh. That's interesting. I'm pretty sure that's working right now, so I'm I'm curious. I'm curious how that's working in practice currently. Good. This is why you write tests. And we can make that whole code like this is just really gross. I'm putting spaces in here manually and then just concatenating strings. It's not the way you want to do that. So let's clean that up. So let's just, I think I'll copy this. Yeah, let's go with that. So copy it, and we'll call this to evaluate that guy. Okay, let's start to take this. So instead of a string, let's start with a vector. And let's go ahead and I'll comment those. And then we'll just conj onto that. Mine. Okay. All right, so I would expect now I evaluate this. Should get that, I hope. Actually, let's get the failing case first. Yeah, so cool. This is exactly what we want. I'll comment these out just to get rid of that noise. Emacs is trying to outsmart me there. Oh, good enough. Okay. So a little cleaner. Just getting to one failure. So we can make that pass by doing that. All right, you get a green check mark. Okay, cool. So we're adding the mining argument if we have it. So if we are mining and we have a mining address, we want to add that. So this should be probably do an into, I think would be maybe the nicest way to do that. So that's going to take whatever we have so far, and I'm thinking about this right. Oops, I shouldn't delete that. Mining adder, and then yeah, that looks right. So we'll take whatever we have as our vector so far. It's going to be thread into here, and we'll add this to it. Is that going to do it? It is. I should wait a second. No. What am I doing wrong? What if I do? I think you should work like that, right? Into a. Oh, I know why. Yeah. Okay. So it's because yeah. Okay. It's because our base config does not have a mining address. So let's we'll make another one. So let's do. By the way, this def inside here is definitely. I do not think something I would do in my actual tests, but for like interactive development, I don't have a whole lot of qualms about doing this. But I'll turn this into something a little nicer, like have a, I don't know, like a. I don't know. Actually, I'm saying that I'm like questioning as I say it. Would I have a def with inside? I might. I don't know. I might just put a def in the test form. I'm not sure that's so bad because I would do this if I had a separate file. I would def some stuff in there. So yeah, maybe this is the way to do it. So let's just take our. We'll call this mining config. So it's going to take the base config and we'll assoc in. Let's see. So assoc going to take the map, then takes the path, and then it takes the value. Oops. So the path we want here. Oh, actually, we don't even need assoc in for this. This is top level. I was thinking it was nested, but it's not. So let's take miner address, and doesn't really matter. We'll say ABC. Obviously not a valid mining address, but you know that's not really the point. Actually, I like, just for consistency, we'll call this miner config. Okay. Oh, and no namespace on that, so I just stepped it. Okay, cool. Now we have failing test. That is what I would expect. So what we want to see here is mine, and then we're mining. By the way, you may have noticed there's a discrepancy between mining adder and miner address. That's intentional, but I don't want to justify it now, but that is an intentional difference. Okay, all good again. Okay, so next thing. We're looking for, by the way, this is probably still not the optimal way to do this. Like, I could imagine. I don't know. It's probably overkill, but oh man, what's that library called? Meander. Like, I think the most elegant way to do this would be you do some sort of like pattern matching of the config into a vector. The trick with that is that would be great if I were writing something that was intended to run in Clojure, but I'm writing something that's intended to run in Clojure and Babashka, and I'm pretty sure that Meander does stuff that is just not going to work in Babashka because there's limits to. Um, I say that, but now I'm really tempted to check. There's limits to what you can do in Babashka. Not everything is there, from JVM and some stuff like some of the macro stuff, runtime macro stuff, I think would be challenging. Anyway, that would be, I think, if I was trying to, like, what's the most elegant sort of visually obvious way to do this? I think a little bit of pattern matching would be nice. But I think that's overkill, and I'm not really confident it's going to work the way I want in Babashka. And because Babashka is interpreted to, like, eventually you get enough complex things in there, it starts to slow stuff down. Okay, so this, let's see here. I wonder, and now I'm looking at this, we could put a let here too. That might clean things up a little bit. So let's do keys. There's a little bit of Clojure destructuring. So mine, question mark, minor address, and then Arweave. So we'll just pull those things out of config. Yep, so I guess that one wasn't strictly necessary, but this one we can definitely clean this up. So minor address, and then minor address, and yeah, let's go ahead and do this too. So we've pulled Arweave out of here, and then we'll pull extra args out of Arweave. And the time has come. So if you are following along this stream and you're interested in Open Web Foundry, it's now time for that. So you just follow this Twitter link, and the top tweet should be about today's stream. So if that sounds interesting to you, definitely go do that, because some of the point of that is live interaction that you can't get here. I mean, you can always watch the video later, but if you want to interact with people who are building stuff on Arweave live, that's something you can't do in a video, whereas you can always watch this later if it's interesting to you. So please go do that if it's interesting. I'm going to keep going for a little bit. Probably won't get the doc up today, so I guess if that was appealing and you like to see that live for some reason, probably get another chance. But yeah, so I just wanted to make sure to say that for anyone who's interested in Open Web Foundry, you might be following along here. Oh, and just as a reminder, that's for people who are building businesses, projects on top of Arweave. I think today's topic is people who are building as part of this round, are showing things off, and then after they do that, they show off their stuff in sort of presentation format, and then there's a little get together afterwards where you can, walk around and talk to people in sort of a virtual gather town environment. So definitely go do that if you're interested in it. If not, I'll keep going for a bit longer here. Maybe like 15 minutes, half hour, something like that. We'll see. All right, extra args, we got that. Yeah, so this could simplify just to extra args. Okay, so what am I doing with this? Yeah, actually, if I have this, I think all I want to do is just do an into and then extra args, because, yeah, they exist. We just add them on at the end. Is there a tidier way to do that? I'm trying to think. I guess the minimalist way would be, nah. I was gonna say I could thread extra args through, but that sounds, There's sort of order I like these things to show up here. Yeah, and actually, with that said, I would think I would want extra args to always be at the end. Maybe? No. No. I want peers at the end. Okay. Yeah, so let's take minor config with extra args, and we're going to do, so now we will do association, and we'll do this, just keep that a little bit. Now let's thread it, so let's take the, we'll take the base config, and then we'll thread it through. So remove this. I guess I could start with the minor config since I want, yeah, I do want the mining. Do I? Do I though? I don't think I do. Let's make these each test individual things instead of testing the combinations. Okay, so this time we do want association, so this is going to take vector here, and so let me get the config up so you can see. So this is the structure we're working with. So basically, there's top-level configuration options that would apply to everything, and this is the base config, by the way, that everything gets merged into. So there's some base config that we're working with. There's top-level options that sort of apply to the whole node, and then we have options that might apply to individual things within it. And what we're dealing with now is this guy right here. So we have a set. Yeah, for non-clojurists, you know, this is the map. That's a map literal. That's a vector literal, and that's a set literal. So Clojure has set literals, which are super nice. Yeah, I was tempted to go on tangent there talking about sets. I'll think I'll refrain. Let's just say, you know, sets are what you would expect. You know, A and B could be in here, and A, I think if you, let's see, let me evaluate. Yeah, it doesn't let you actually put a duplicate into a set literal. Oh, my linter tells me about that too. So yeah, things can only be once in a set. Okay, so we got the, what am I doing? Not our address, Arweave. So we're going to associate Arweave peers. That's the path to our thing within the structure. So Arweave and peers. And we're going to put in there a set. And I'll just grab, we don't want this whole thing, but I'll grab, say, 2 of these. And these are just the official Arweave peers listed on the Arweave website. When you're starting a miner, you want to start out with trusted peers, because if you connect to untrusted peers, they could be on an entirely different chain and you wouldn't know it. Okay, run that. All right, so Arweave args2, and we'll got our config with extra args. That's definitely going to fail. Get the REPL up here. Oh wait, I went on. Yeah, sorry, I was meaning to do extra args and I did peers instead. So yeah, I guess since I went down that path, let's get peers working. So I'll leave out extra args. Sorry, you get out on a tangent somewhere describing things. Okay, so this is going to be, I guess I'll leave this for the time being. I commented that, but I'll leave that because my linter will complain if I don't. Okay, so pull the peers out so we can just do if we have peers. And okay, so what does this look like? This is going to be slightly more complicated. we want to, yeah, we should just be able to map over those, right? So what we want to do is we'll do another into. So into the thing that's getting threaded through here. This might be a slightly confusing construct if you're not familiar with Clojure, but this is like the threading macros that I've explained before, you know, where you're threading a thing through a bunch of you're threading a thing through a bunch of functions. Same thing, except it's like a conditional version of that where, okay, here's your incoming thing, and if this condition is true, it gets threaded through this expression. So hopefully that clarifies what's going on a little bit here. So this is actually going to, unlike a traditional branching construct where you're just going to take one of the branches, this is actually going to evaluate each of these, and for each of these that's true. Ooh, I can also simplify that. If I can type. For each of these that's true, it's going to end up evaluating this and threading whatever is the current, last version of this thing that was constructed through that. So if we add mine here, the thing that gets threaded through here already has mine in it, and so forth. Okay, so do the same thing here, and I think what we want to do here, so we're taking a set as an input, and what we want to spit out is something that looks like it's going to be a vector, and it's going to appear, and then IP address, and then peer, and a different IP probably, but you get the idea. Okay, so I think probably the most straightforward way is you just take a map. Yeah, I guess there's a few clever ways you could do that. Let me think. So we could zip map. Let's see. Let's do what I think it does. I think so. Yeah, that might actually be. I think the sort of obvious way to do this is something like, this, where you just do peer p. It's maybe the most evident way, and just do that over peers. Let's do that first, and then I'll do the sort of fancier thing, which I think I will use. There's always a trade-off between, like, I don't know, I think how fancy your code is and how evident it is. Or there's often a trade-off, to say, not always. Okay, what does that give us? Interesting. So we're not quite getting what I want. Right, we're getting, we would need to do this. We need to do mapcat, which is going to concatenate the output for map. Okay, that should give us what we want. And of course, our test is not right because we're comparing against something that's. I'll just clean this up a little bit. So. Intentionally failing. Okay. Okay. So what I was going to propose was actually doing. Well, I'll write it out, and then we'll see what. So you can do zip map, where you're going to take repeat. Ooh, is that the right one? Repeat. I think it is. Take 10, repeat, here. Yeah, so that's basically giving you an infinite sequence of peer. just repeating, taking 10 from it. So what we can do is repeat peer and then peers. So let's do that. Let's do that right here. So that. So repeat A. So this should give us. Let me. I don't think that. I'm just guarding myself against whether that's infinite or not. Take 2. Why? Interesting. Oh, because it's yeah. Okay, yeah, that makes sense. Actually, no, it doesn't. Like 10, repeat. A, B. This is the part where, like, ooh, this would be much better if I could get a little pairing feedback here. So that works. Why does it not? Why does it not work for that? Okay. I'm realizing as I'm typing this that zip map isn't actually what we want either. So I think we'll probably just go with this sort of simple evident thing. I don't fully understand why I'm getting A2 out of that. I would have thought that that would be the same. Okay. Probably doing something silly that. Oh, yeah, I am doing something silly. So it's a map, so the keys can't be duplicated. Duh, yeah. So I mean, that's the reason you don't want zip map in the first place, or one of the reasons. I'm trying to think if there's anything else that would fit better there. Oh, interleave. Yeah, interleave. So this, yeah, let's try that. So this, yeah, I like it. Let's see, does that do what I want? Bingo. Okay, perfect. That's actually really nice. So, and then that gets rid of the concatenation too. So yes, I like that. Interleave. Boop. Repeat. Peer. Okay. Okay. Let me clean up some of this mess. Okay, so basically interleave. I mean, I think this is actually a pretty descriptive way of writing this. Interleave is going to take a thing from here, a thing from here, and then a thing from here, and a thing from here, so forth. And repeat, again, is the infinite sequence of peer, so on and so forth. And it terminates when one of the sequences run out. So it doesn't matter that interleave is, or sorry, it doesn't matter that peer is infinite because we terminate when the other sequence runs out. So that's a pretty nice way of doing that. Okay, so let's see. We do get what we want, and let's write that out here. Oop, just copy it. I don't know if that's always feel a little weird when I copy from the result that my thing outputted into the test, but I don't know. We visually inspected this thing we expect. I think a real TDD hardliner might be like, no, you should write out the expectation, see it fail, and whatever. This is effective too. Or I thought it was effective. Why is that not working now? Didn't we just run this? Weird. Mind fail. What did I change that would have caused that? Into interleave. I wonder if I somehow had redefine that. Alright, well let's evaluate each of these. This could be RCF doing something weird for all I know. Oh. Got it. Yeah. So the base config has peers in it. Let me think about that. Yeah, let's just make this a little simpler. So mine question mark true. And then, by the way, for people who are not familiar with Clojure, commas are white space in Clojure. They're just there for visuals. It's the same as having that. But if you have a map that's all on one line, sometimes commas help a little bit. Minor address and ABC. Yeah. Okay, config with extra args, with peers. Yeah. There we go. Okay, closer actually. So we're still getting that one failure. So the base config. Let's call this def min config. Minimal config. And this will be config with peers. It's actually kind of invalid if you don't have peers. I should probably be. I guess right here I wouldn't fail it. I think I do actually fail that via schema validation. Yeah, so this would be the wrong layer to fail it. That's disappears. Okay. Okay, so let's call this one minimal config. Yay! So there we got everything passing. The only thing, so I think I'm just going to finish this exercise and then probably wrap up here. I kind of want to live stream the DocOps stuff, but I'm afraid I'm going to get to it before my next live stream. We'll see. I might try to save that. I'll talk briefly about what I was going to do there and attempt to save it for my next stream. Maybe I'll record it either way, even if I don't live stream it. Because for some reason I think people would want to see stuff about argument parsing in Babashka. I don't know if that's really accurate, but I don't know. I think it's kind of cool. And it's something I'm looking forward to doing. All right, extra args. Let's wrap this thing up here. So this is not with peers, and then boom, config with extra args for reals this time. Is it actually called extra args, or is it like extra? Huh? Ooh, extra arg. That's not right. Finding a typo in my spec here. Oh, no, it is. That's the singular, and then I do a collection of that. Okay, fair enough. Probably should have called that like Arweave arg instead of extra arg, but I'll remind myself to do Arweave. Maybe rename that. It's extra arg. It's like all. all the args. They're strings and they're not empty. Might as well say what it is. Okay, so yeah, so this would be extra args, and I think, hope I'm getting this right. I'm pretty sure sync jobs. Yeah, pretty sure that's the one. So this is just an arbitrary Arweave, and that is a vector, not a set. So because order matters. Okay, so sync jobs 10. So out of this, we should get. Yeah, I'm realizing I do this like backwards from how I think traditional TDD folks tell you. It's like I write the code to do the thing, and then I write a test that shows me that the code is doing the thing, but the test doesn't pass. So I don't know. Maybe I'll really get myself in the habit of doing it the other way. But the point is, you see that there's a failure. You make the thing that matches the failure to kind of double check, because it's never reassuring. So like I could do this. Actually, let's just do this. This is the thing I definitely don't like doing, which is you write the code that you think will pass, and you write the test that you think will pass, and then you run it. Oops. Well, it clearly won't pass because so I'm kind of thwarting my own like example here, because it's of course it's going to pass, or not going to pass because I did that. So sync jobs 10. Oh, did that? That's interesting. What's going? Oh. Right. Yeah. So this should be. Actually, let's do this all with minimal. I'll get back to what I was saying about the whole passing versus not passing. Minimal config. Just trying to make these as sort of minimal and focused as possible here. Although then we don't see it adding. No, I take it back. I will use the minor config. Because if I use the minimal config, I don't really see it adding anything. I just see it outputting a vector, so I think it's probably a better test. Okay. No. I take it back again. Minimal config is enough. Let's do that. Yeah. Mine true. Why is there no? Oh, that's because I edited that. This should be, yes, this should still be mine. Okay, cool. So yeah, I definitely thwarted my. It's never reassuring to me when I write the code and I write the test that should pass, and it passes, because it's like, did it really do anything? I don't know. So I often do it where I make the test so that the test is kind of incorrect, and then I see, okay, yeah, it's doing something. I kind of see my differences between the test and the thing, and it's like, okay, now if I change this, I know that's what it should be doing. Doing it the official TDD way of like writing the passing test versus probably slightly better. So checking your expectations a little better. But anyway, make it fail somehow first, and you see a difference, and you can go from there. Okay, I have a little bit of work to do here just to replace this, and then have a version, like another little thing that stringifies the just as like a string join on the vector we're producing. But basically, yeah, this is much cleaner. And hopefully I demoed something about how you use RCF. RCF also, like, I'm not sure, it's designed to be a very simple thing. You can also write descriptions of these, testing a thing, hopefully a better description than that. And they'll, let's just make that fail just so you see what the output looks like. So you get some description with your tests. So you can have little string descriptions. Has some wildcards you can put in there. You can do unification. Has some REPL-like bindings for things. And you can nest test. But it's designed to be very simple. Not a lot of surface area things you have to learn, so you can get right into it. And I think, I think I showed what I believe is sort of the core of the intended workflow here. So hopefully that was interesting. I have essentially another version of this to do with how I'm building the environment variables. Um, it's going to be pretty much a repeat of what I already did, so I don't think showing that would be super useful. The thing I didn't get to, which I thought I might not, just because there's only so much you want to fit into one stream, is I think I have it open already. So I wanted to take right now. This thing is using Babashka tasks. So there's like a little shell script wrapper, which does a bunch of like checking to see if Docker Compose exists and if Babashka exists, and downloads and puts them in the right spot. Just trying to make the really initial user experience very seamless, or as seamless as possible for running something on the command line in Linux. And then at the end, it just invokes Babashka tasks or prints out the output. This is a pretty good way to get started. I think ultimately, when I looked at how this works, Babashka tasks are not the right tool for this, because I want to have more arguments to these things. And as soon as you get into passing arguments to tasks, Babashka, it's not like it hinders you, but it stops providing a lot of extra help. I think the right way to think about Babashka tasks is more like it's a makefile, right? It's going to be a bunch of routine tasks that you don't parameterize a whole lot that you use to run something. So for this use case, I'm thinking about replacing Babashka tasks with doc_opt, which doc_opt is just a language for specifying command line interfaces. Basically, you specify a documentation string for your command line interface. It parses that and then parses the input to your command line tool, whatever it is, and gives you a data structure to work with. And there's a version of this for Clojure, and the Nubank, which is a Clojure development company, which is now the umbrella which Cognitect is under, doing financial stuff. Clojure development company is very, very abstract. They do like banking stuff, just to give them proper shout out. And they've adapted the Clojure doc_opt to make sure it works with Babashka. So I was going to take that and switch around the argument parsing. I think I'll probably save that for my next live stream, because I think it'd be, I don't know. I guess I'll remain non-committal on that. I might get to it before then, but if I do, I'll at least show how it turned out on the next one. So that's the thing I didn't get to. I guess I'll promise to at least show it on the next one. Again, I'm not entirely sure why I think people would think that's interesting, but it's interesting to me. So, and I guess as a last note there, I would say too, if people have suggestions of things they want to see, feel free to like tweet at me or tell me like, oh, your doc_opt thing, that sounds great, or no, you fool, why would anyone want to listen to a stream about that? So suggestions welcome. I think I'm going to end it here. Apologies for the late start. I don't know how to prevent that, honestly, because like I tried everything out ahead of time. Then when I went to do it for real, had problems. Maybe don't try it quite as far in advance ahead of time. Anyway, rambling. I'll wrap it up here. If you stayed through the whole stream, awesome. Thanks for that. And if you're watching it afterwards, awesome too. And I'll see you next week. That's it.